So what I got in my hands here is what we call a catheter products. Catheters are little plastic tubes that we run through lots of different pathways in the body, but quite often through blood. One of the very first technologies that we developed was a technology that actually changes the chemistry on the surface of the material, and by presenting that diverse chemistry, we can actually fool proteins as they're interacting with this plastic to think that they're still swimming around in blood. And if you can do that with proteins that are involved in the clotting pathway, you can stop clots from happening on these foreign surfaces. And a blood clot is a problem because if you create a clot and then the flow comes by and breaks it off, that clot goes downstream, could plug a very important artery. So this technology now allows patients, for instance, who are in chemotherapy to have one of these catheter lines in feeding the therapeutics for upwards of 2 years without inducing a clot. It reduces the incidence of infection because once you form clots are proteins, and bacteria love protein surfaces, you reduce the incidence of infection by 800%. This is another device that has benefited from that same additive technology. It has about 6,000 little fibers in here. If you actually had to make these fibers and then go coat them individually, it would be hugely laborious. What we get to do is extrude these fibers, and as you extrude these fibers, the additive migrates to the surface. And those additives, again, reduce clotting. Every time a patient undergoes a dialysis treatment, it's about $8 worth of anticoagulant that's used. In North America alone, somewhere on the order of 1 million dialysis procedures done a day. Even if you reduced the amount of heparin by about $1 worth, that would be $1 times 1 million times 365 days a year. You can see the impact that that has on cost of healthcare. So it's a great story of chemistry of materials, production of materials, knowledge of biology, all the knowledge of all those proteins, and how those proteins interact with blood elements that induce clotting. That's about 3 decades worth of research. This is why we fund fundamental research in Canada, so that we can take that fundamental knowledge and package it all together in the end to create an impactful technology like this.